is next week we're reinventing. Mr. Buckerfield and I are going to take over Spirit Club. Spirit Club is coming back. Oh yeah.
Oh my gosh.
So we need members.
I'm down.
I'm down. What we'll do, we'll meet, we'll make some signs, we plan pep rallies, we'll do all the spirit. So you guys don't know Mr. Buckerfield yet, he's a junior teacher. But he's a little nutso.
Oh, you've heard him. They've heard him.
You've heard him. He's the loudest person in this building. So, when you walk by about the middle of the hallway, you just hear this loud person, that's Mr. Buckerfield. But we're starting Spirit Club. So you got to put that on your calendar. I'll let you know when it's starting. We'll have pizza after school. We'll have some good times.
I'm coming then.
Yep, Mr. Parker's coming. So, okay, now homework-wise, let's take a look here. Even if you didn't do it, you better pay attention because I'm going to call on you anyway. All right? So, domain and range. It is hard. It is hard. But we got to figure this out here. So, we're going to look at number 11 here. 1 through 14. And here's what I'm going to do for this one here. For 11, I'm going to put the point here. This is -2, -2. This point right there. And this point is -1, 0. And this point is 0, 2. And this point is 1, 0. And this point is 2, -2. All right, Jeff, how do we figure out what the domain is? Any ideas?
Yeah, not really.
Okay. The domain, which coordinate is it? Is it the first or the second coordinate?
The first one?
It's the first one. Well, what's the first coordinate of this number, or this point? What's the first one here?
-1.
What's this one?
0.
What's this one?
1.
What's that one?
0.
2. All right, you just gave me the domain. You gave me the domain. It's all the x values. There's -2, -1, 0, 1, and 2. Okay? You gave it to me. Alex, do you know the range? Which coordinate's the range?
-2, 0, 2, 0, -2.
He says -2, 0, 2, 0, -2. He is correct. Now, the only thing here, little condition, don't repeat a number. You don't need to repeat a number. If we write it down one time, you don't need to write it down again. So we're going to write down -2. We're going to write down 0. We're going to write down 2. It goes back to 0. I don't need to write it down. I stop right there. That's my range. Those are the 4. Those are the 3 values. Okay? So this is the second value. Second value for that one. So for this one here, okay, that is the point -2, 3. This is the point 0, 3. This is the point 2, 3. And this is the point 4, 3. Okay, so for 12, domain, range, that's an R there. All right, domain. What's that going to be? Emily, what do you think?
-2, 0, 2, 4.
-2, 0, 2, and 4. Now, I didn't really specify. You do want to put it in order, like smallest to largest, and she did that. So -2, 0, 2, and 4. All right, what's my y value, Diana?
Y would be, we are on 12.
Yep.
3, -3. Is that -3? The 3? Yeah. 2. I can't see.
Okay, look at all these points. They're all in the same spot across here, right? The y value for each of them is just a 3. It repeats every time, right? So, Damien, what do I put down for my range? 3. That's it. 3. My range is the number 3. Okay? That's it. Done. All right, now 13. All right, this is different. These are individual points. If they're individual points, then individual numbers will be your domain and range. So, but now I got more than just individual points. Here's how you do your domain. You want the x value, the furthest x value on the left, which would be right here. I'm going to write the whole point. It's -4, 6. And then I'm going to go down to the x-axis. I'm going to put a mark. And go to the furthest point on the right. That is the point 2, 3. And so right here, that's 2, 3. It covers that whole area. Okay, now it swoops down, which is fine, but it goes that whole area from left to right. How do I write my domain? What do you think? What do you got there, Lucas?
-4 is less than or equal to x less than or equal to 2.
All right, good. Domain. We got to write this. This is why we do that compound inequality. -4 is less than or equal to x is less than or equal to 2. So we do that. Agree with that. Because it hits everything from -4 to 2. My range is the y values. Go to your smallest, lowest y value. All right, maybe not as obvious. What do you think? Look up there. Where's that lowest y value, or what is the lowest y value? Addie Barrios, what do you think?
For 13.
For 13.
Yeah, she's like,
Would it be,
nothing.
What's the lowest point on that graph?
2, 3.
2, 3, right there. I think there's a lower point.
Oh, 0, 2.
Good. I want to make sure because this is the furthest point on the right doesn't mean it's the lowest point. You're right there. 0, 2. So I'm just going to put. And the highest point is this same -4, 6. So I'm going to go on the y-axis. This is where my range is. It covers all those values. There's my range. It's the y values. Addie, do you know how to write it?
I was really confused on this one.
So what's the smallest y then?
0, 2.
Just give me the y coordinate of that. That would be
2.
2. So then you do 2. Since it hits at that point, you do less than or equal to y. And what's the highest value it hits?
-6.
6. Less than or equal to 6. So here we're trapping it. We're going to say it's bigger than 2 but less than 6 or equal to. So that would be our y values. All right, if you didn't do 14 or take a look at 14, be ready to answer. Think about it. What it would be. All right, what's 14 going to be? Now, they got open dots. Remember, an open dot means it doesn't include the point. So here's how it's going to change here. Instead of less than or equal to, it's just going to be less than. No equal to part. So domain. Range. All right, Austin.
0.5 is less than x, which is less than 1.75.
Okay, good. Good. Now this is you got to watch how this is labeled. It goes 0.5, it goes 1, it goes 1.5. So everywhere in between, it's like a quarter. So
Why
that's
did you put or equal to, guys? Why?
The circles are
Nice job. Nice job, both of you guys.
Circles are open. And that last one in the range here is this is at point. The lowest value it hits is right here. The highest value it hits is right there. That's your range. Okay. And so it's going to be 0.25. 0.25 is less than y is less than 1.5 for that one. All right, now write on your homework. I want you to do the warm-up. I'll move it in a second. So let's see what we figured out. Right on there. And I'll move that up here in a second so you can see number 4. Well, you know what? It is for sure.
Alright, so you got two things you gotta make up, right? Alright, you know how to get on camera. Okay. Alright. What we gotta do is next week, we'll get the test, that's the plan. Now, if you just really go. But we just gotta get it No, you don't have any study halls or? No. What's that?
Guys, can I slide it? Slide it? You guys.
I just meant overall, first period, you have a study hall. Okay, so what we can do is get some of that stuff done.
All right, I'm really interested in what you're gonna put for number 4.
I'm interested in, 4 also. I don't know if I'd say really interested. I'd say a little bit interested.
A little bit.
I'll go with that.
I don't like Mr. D-Lab's blue dots on a blue graph.
Man, always.
I care about you guys. I don't think he does.
What? One input into more than one output is not a function. So 1/2 is actually goes to how many outputs? 1. We'll see the arrows. Oh, this is 3. So we did 3 different ones. So that means it's not a function. Because you see how I get these words? So it's not a function because input 1/2 has input.
Give you another half minute. Mason, that's 30 seconds. All right, man. Just making sure you understand. All right. Guys, that's okay if you're not done. Let's just check these out here. All right, first of all, number 2. Is this a function? Number 2, Rylan, what do you think? Is this a function?
Which one? Sorry.
Number
Hey, you
skipping
number 1 for any reason? You still like number 1?
I didn't know it was up there. You know what you said you wanted to do? I'm going to do right now. Rylan, number 1. Is that a function, Rylan?
No.
Okay. -5, 0, 5, 5. Do they have different outputs? 5's repeated. This is not a function. Not a function. You guys see that? Right there, boom, not a function. How about number dos cetos, 2? What do you think, Lindsay?
Not a function.
How many agree it's not a function? Yeah, guys, 1/2 is being repeated. The input's being repeated with different outputs, not a function. If I would graph those points, they would be all 3 on top of each other. Okay, wouldn't pass the vertical line test, would it? Okay. Don't try this at home. Okay? Don't try drawing a line like that at home. All right? Is that going to pass a vertical line test? It sure does, doesn't it? Nowhere does that upside down V hit that vertical line in more than one spot. So 3 is a function. 3 is a function. Okay, now, domain. Is the domain my x values or my y values, guys? X values, right? So domain. What's my farthest one over here? X values. -2. Then it goes what? -1, 0, 1, 2. There's your domains. Everybody okay with that? Now, you notice when I got a set of points, I'm going to make a list, right, of my domain and range. Okay? Now, range. Why my y values? What's my lowest y value, guys? Isn't it 0? And then it goes up to what? Goes up to 2. Now, is 2 repeated? Don't just write it one time. And then what's my upper y value? That's the only numbers you guys should have for your range. Okay, 0, 2, 4. Don't repeat when you list, Juan. Just like you ride a bike kind of crazy. Dude, was I lying or seeing things, or were you really singing? Huh? Okay, all right. I do that too sometimes.
Just saying, Juan, I gotta do my homework.
Juan,
Make sure I do my algebra.
it's okay if you talk to yourself, just don't answer. Okay, then we got some issues. Okay? I mean, Diana does both, and I'm kind of worried about it. What? Where am I? All right, just kidding. All right, now, guys, I like my domain. I like doing this. Put it on the x-axis. Domain's x, left to right. So where's my smallest? What's my smallest? What do we got here? 1. Okay, so this goes up by what? 0.5? Right? -1/2. So that's my low end. -1/2. Okay? What's my upper end? Let's see, this is 1, 2, what's that? 2.5? So how would it be? -x is less than or equal to x. X is less than or equal to 2 1/2. The scale there was kind of funky. You had to see that. Okay, now, the y. My range. Well, let's see. It goes up to here, and it goes down to here. Does everybody agree? What's my lowest range value, guys? Negative what? -1/2. Is less than or equal to y, but what's it go up to, guys? 1.5 if you guys did decimals, or 1.5. And there she is right there. Okay, how'd you guys do on that? Is it a little easier? Wasn't good? Wasn't
So
good?
they still struggle with that last one.
Okay.
All right. There's a homework for the.
Oh, thank you, sir. Appreciate it.
All those copies.
Yeah, thanks.
For that one. All right. We're still going to stick in 3-1. We still got to finish a couple things off. Domain and range, we're going to continue to hit. But one last thing that's in this section we didn't hit yesterday. It's called the independent and dependent variables. These just match with the x and the y. They're just different names for the domain. The domain is usually the x. That's also what we call our independent variable. Did everybody get the guided notes for the day? I didn't miss anybody, did I?
Everybody get it?
So we're on those. We got to talk about whether something's a function. If the x value repeats, it's not, or if it doesn't pass the vertical line test.
Should put it on the forward.
I didn't put anything in the
Okay, make sure we have 1, 2,
So,
3,
for that one.
4.
All right, so let's take a look here, day 2. All right, definition-wise, it's been a little while here, and I'm not sure what your introduction was to this last year. Now, the variable that represents the input, we've talked a lot about input versus output. Input is independent, also known as the x, because it can be any value in the domain. The variable that represents the output is the dependent variable, because it depends on the value of the independent variable. Okay, when you have an equation, what you plug in for is we always plug in for the x. We input for the x. That is the independent variable. This is the dependent. Now, it's a little bit easier if I just give you an equation. But now here's the deal, is a lot of times I'm just going to give you a situation. And you have to pick out the variables, and you have to label one independent versus dependent. And that's all we got to do for this. Now, it doesn't even list what the variables is. We have to draw that out of the statement. So a painter must measure a room before deciding how much paint to buy. Kind of what are the two things we're dealing with? Let's see if this is making, sinking in at all. What are the two things we're dealing with? Maddie?
The measurements of the room and how much paint.
Yeah, those are our two good. That's very good. One of them has to be independent, one of them has to be dependent. So let's just list those. So you can say measurements of the room, or you can say size of the room. Either those would be equivalent. But we got measurements of the room. And then we got how much paint. I'm just going to put how much paint, like typically you say, that we need to buy. One of them's the independent, one of them's the dependent. Which one depends on the other? Ava, what do you think?
How much paint?
That depends upon what?
The measurements of the room.
Yeah, measurements of the room. So which one's the independent variable? What do you say, Ava?
The measuring the room.
Good. This one here is our independent. It controls the situation. If the size goes up, then the amount of paint will go up. This is the dependent. You're just not going to randomly go to the store and buy, 10 gallons of paint if you don't know how big the room is. Or if you do, you're not very smart. Okay? So you want to know, all right, what's the size of the room? That's going to tell me how much I need to get. So that would be that first A one there. This should say, that should not have a T there. A veterinarian must weigh an animal before determining the amount of medication. All right, so what can we pull out of there? What are the two just variables before we label them independent and dependent? One?
Weight of the animal and then how much the amount of medication.
Good. Those are our two variables.
Yep.
Okay, our two things we're working with. So the weight of the animal, and the amount of medication. Okay, which one depends upon the other one? Also,
You remember medication.
amount of medication depends on the weight of the animal. So that means the weight of the animal is the independent variable. Independent. And the amount of medication is the dependent. Okay? Because they're going to say, I need some heartworm pills. And they'll say, well, how much is your dog weigh? Okay. Or I need a seizure medicine. We'll say, how much does the dog weigh? So the amount depends upon the weight. Oh, yeah. Buffet. Old Golden Corral. So think about this as you're going out with your family. Or I'm taking my family out and I'm paying. A buffet charges $8.95 per person. So there's a little bit, like it's not specifically stated, but we can infer what the two things we're working with. What are the two things we're working with? Ava?
How many people and how much the buffet charges?
How many people would be 1.
And
And
then how much it costs for the people.
And I would just say total cost.
Total cost. Yeah.
Total cost. So, amount per person or total cost, and I'm just going to change it just a little bit for the one. I'm going to say just number of people going. Okay. So number of people. Which one depends upon the other one? Awesome.
Total cost.
Total cost depends upon the number of people. So number of people is independent. Total cost is dependent. So you got to take a situation and we got to say, all right, what depends upon the other? And that cost, I honestly can't think of a case where it hasn't been the dependent variable. Okay, I don't want to say always, but it's usually, in my experience, it's always cost is the dependent. Because it's going to depend upon, like, I don't know, how much groceries you buy or how many people attend the buffet, or it always depends upon something. Okay, all right, now let's take a look at this one here. And we're going to add in, it's on the back. Okay, it's on the back. Water pressure is 0 psi, pounds per square inch, at sea level, and increases by about 0.44 psi for every foot an object descends in the water. So have you ever dove down into a deep pool? You feel more pressure. And that's why, if objects go deep, like submarines have to be built very strong to withstand the pressure. Does the situation represent a function? All right, let's see here. I'm going to just say yes for now, and I'll explain in a second. But let's do independent versus dependent variables. What would those be? Okay, what would be like the two things that we're kind of measuring? Austin?
How far you go below sea level
Okay.
and the PSI.
All right, so I'm going to say depth of the object, and the PSI, pressure. I'm going to say pressure, and I'm just going to put that PSI. Which one depends upon the other? Which one depends upon the other? What do you got, Griffin?
The pressure depends on the depth.
Okay, good. So that is independent. And now this is dependent. For this. All right, now is it a function? Here's a question you got to say. Will the depth of an object give you more than one pressure? So if something's at a depth of 10 feet, can it have two different pressures? No, so that means it's a function. Okay, if there's ever a case where something can have two different readings, then it would not be a function. Like your weight is going to be a function, each person's weight. You can't have two different weights at that moment. All right, now here's where we got to be really careful here. A whale dives from 1,000 feet to 3,500 feet. Find the domain and find the range. Domain. Those are the values of the independent variable. Range are the values of the dependent variable. Okay, now from here you should be able to tell me what the domain is. All right. Or at least have an idea. Awesome.
1,000 and 3,100.
1,000 and then 3,500.
Yeah.
Now, you agree. How do we write that? Because it says it dives from 1,000 feet to 3,500. So does it go all the way from 1,000 to 3,500? Does it hit every foot in between? Yeah, it's going to go all the way down. How do I write this domain? Okay, you just can't say 1,000 and 3,500 because it's more than just two values. It's all the ones in between. Gavin, you got any ideas how to write it? Is that a maybe?
No.
Ellie?
Do the thing where like you do the 1,000 is less than or equal to X and then less than or equal to.
Yes. That's it. So 1,000 is less than or equal to X is less than or equal to 3,500. That means it has to hit every value in between. It has to hit them all. That's our domain. That's what we plug in for feet. That's the depth. Now, what's our range? Our range is going to be our what? PSI. How do you figure out the pressure for those objects? Can we? Yeah. What's it tell us to do? It's about 0.44 for every foot it descends. So at 1,000 feet, what's its pressure? You know how to figure that out? Lucas?
440.
Yeah, how'd you get that?
I multiplied 0.44 times 1,000.
Good. Pressure, from what they told us, equals 0.44 times the number of feet. So you're going to have to do a little math. We're going to have to take 0.44 times 1,000. And would you say that was 440? So that's 440. Now take 0.44 times 3,500. The highest or the lowest depth the whale goes. What's that? 1?
1,540.
Say that again.
1,540.
1,540. We agree? I just want to make sure we're agreeing on that. Okay. Now, how do I write the range? How do I write the range? What would be the lowest pressure that he's under?
440.
440. What's the highest pressure, Austin?
1,540.
So we're going to do 440 is less than or equal to y is less than or equal to 1,540. So you got to figure out, all right, what is the actual pressures this animal feels? So you actually got to do a little bit of the work there. The domain I can just take from the, I know I did that. Domain I can just take from the 1,000 to 3,500. All right, take a look at that last one there. See if you can identify the independent and dependent variables. I'm going to tell you it's a function just so you don't have to worry about that. See if you can identify independent versus dependent. If you're not quite sure, don't write anything down so you have to erase it. If you're not quite sure, just wait. And we'll put it down. All right, so just our variables. Carly, any ideas what the two things we're looking for are? Perfect. So number of hours rented, and then cost. Number of hours rented, and then I like to put total cost because that can be deceiving if some people think, well, is it the deposit or is it the amount? It's total cost. All right, number of hours rented. Which one depends upon the other one? Okay, which one depends upon the other one? Lucas? Total cost depends upon hours rented. So independent is right here. Independent. And then total cost is dependent. Now to figure out the total cost, we're going to have to come up with a dependent. That's an N and a T. And a little equation. So the cost, I'm going to call it C, is going to equal $100 plus $200 per hour, right? So that would be $100 plus 200H. Domain. All right, this is a little bit different than the other one. The domain is going to be the number of hours. What does it tell us? Does it give us some conditions about the number of hours?
2, 3, 4.
That's it, right? How do I list the domain then?
2, 3, or 4.
2, 3, or 4. You don't do the less than or equal to because it's either 2, it's either 3, or it's 4. It's nothing else. That's your domain. Our range is now the cost. Our range is now the cost. So you're going to have to figure out what's the cost for 2 hours. Okay, Ellie? $500 for 2 hours. Let me go up to my equation just to make sure. So 2 times, yep, 2 times 200 would be 400 plus 100 would be 500. So that would be one of my members of the range. What's the cost for 3 hours? 700?
Yeah.
700. What's the cost for 4 hours? 900. So here you have specific values. Like the whale went all the way from 1,000 feet to 3,500. He went the whole way down. This one here, I can only rent it for 2, 3, or 4 hours. So look at those differences. Okay, good. Now here's what the deal is. Page 117. It's really not a lie. I need you to do this. Okay, I need you to do this, Matt. And then you can put on the back, page 117, 15 through 18. Okay, the worksheet is essentially what we did yesterday. I wanted to hit that again. The problems in the book are from today. Okay. So however you want to do it, but you can just put those problems from the book on the back. Make sure you write that on the top of the worksheet or somewhere. Okay.